In this lecture, we are going to study about Einstein's coefficients. This is lecture 2 of unit 4 lasers. Now, it is seen that in a collection of atoms, all three transition processes occur simultaneously. What are these transitions? The first one is absorption or stimulated absorption, spontaneous emission, and stimulated emission. So when you have a system, you give energy to the system. Then the atoms will absorb energy and go from lower energy state to the higher energy state. Next, from the higher energy state, they will come down to the lower energy state either by spontaneous emissions or by stimulated emissions. What is spontaneous emissions? Particles can come down from the higher energy state to the lower energy state by themselves. They don't require any external energy to do it. Whereas what do you understand by stimulated emissions? Stimulated emissions means particles or atoms come down from the higher energy state to the lower energy state only under the influence of external energy. That is, when external energy comes and strikes them, then these particles will come down. Okay. Now both the process, what is it? Stimulated absorption and stimulated emission require external energy. Stimulated absorption is from lower energy states to higher energy states, whereas stimulated emission is from higher energy states to lower energy states. Now let us see that. Let N1 be the number of atoms per unit volume with energy E1. N2 number of atoms per unit volume with energy E2. You knew the energy density of interacting photons. When these photons interact with atoms, both upward and downward transitions will occur. Here we have taken two energy levels, an energy level E1 and an energy level E2, two energy levels, wherein N1 is the number of atoms in energy level E1 and N2 is the number of atoms in the energy level E2. What happens during upward transition? The stimulated absorption rate is given by N1 U nu B12, where B12 is the Einstein coefficient of stimulated absorption, and we have already seen N1 is the number of particles in the energy state E1. What about downward transitions? The excited atoms may come down either by spontaneous emission or by stimulated emission. In downward transition, by spontaneous emission, the spontaneous emission rate is given by N2A21, where A21 is the Einstein's coefficient for spontaneous emission. Here we don't have the term U nu, energy density, because for spontaneous emission, the atoms or the particles don't require external energy to come down. What about by stimulated emission? The stimulated emission rate is given by N2 U nu B21, where B21 is the Einstein's coefficient for stimulated emission, and we have already seen N2 is the number of particles in the higher energy state or the energy state E2. Under thermal equilibrium, number of upward transition is equal to number of downward transitions per second per unit volume. Okay. So combining this, what do you get? N2A21 plus N2 U nu B21 is equal to N1 U nu B12. That is, on one side we have the downward transitions and on the other side we have the upward transitions. From expression 1, U nu can be written as A21 N2 divided by B12 N1 minus B21 N2. Dividing all the terms by B21 N2, we arrive at U nu is equal to A21 by B21 into 1 divided by B12 N1 divided by B21 N2 minus 1. By substituting N1 by N2 is equal to exponential of h nu by kt from Boltzmann distribution law, we get an expression for U nu is equal to A21 by B21 into 1 divided by B12 by B21 exponential of h nu by kt minus 1. We shall keep this as some expression number 4. Above equation must agree with Planck's energy distribution radiation formula, which is U nu is equal to 8 pi h nu cube by c cube into 1 divided by exponential of h nu by kt minus 1, wherein we know h is a Planck's constant, nu is the frequency, c is the velocity of light. We shall take this as some expression number 5. Comparing equations 4 and 5, we arrive at V12 is equal to V21 and A21 by B21 is equal to 8 pi h nu cube by c cube. The coefficients A21, B12 and B21 are known as Einstein's coefficients. So in this particular lecture, we have studied about Einstein's coefficients, which gives a relationship between spontaneous emissions and stimulated emissions, and how a laser functions using this phenomenon of stimulated emissions.